After my Viva, I want to share with you what I'm doing here in the University of Surrey. This is Monterey. Welcome to my cosmic kingdom. I'm trying to understand what is the galactic influence on the star formation process in molecular clouds. I know, it sounds a little bit complicated and over the top, but don't worry. I'm going to do a series of episodes and I'm going to try to guide you and explain what I'm trying to do. So today we are talking only about molecular clouds. I'm going to show you here a render of one of my favorite video games, Ascendancy, and this is the introduction, and you can see there's like a spiral galaxy. I know the graphics are not so cool, it's a 1995 game, but you can see you zoom in the galaxy and suddenly you're in these dark areas, and entering these dark areas are called molecular clouds, and they are the birthplace of the stars, and if you keep on zooming you will see planets. So, but what is a molecular cloud? So molecular clouds are clouds of gas made of molecules. So that's it. That's so intelligent. It's just an incredible name. And what they are is just accumulation, aggregates of gas and dust along the spiral arms of the galaxy. So here you have a nice picture of a galaxy, and you can see here in the spiral arms there are like very different line of dusts. If we have a look at our own galaxy, so we don't see the spiral structure because we are in it. That's another good topic for another episode. So you can see here how along the structure of the galaxy there are some certain areas that are dark. That's again dust blocking the light from the stars. So what makes this molecular cloud so special is just the fact that because the gas is able to collapse, it can keep on collapsing until it forms a new star. So you will think that, well, it's just gas collapsing, those are like really boring entities, just gas. But no, because in the moment a star is created, then if the star is massive, it will start emitting ionizing radiation and winds, and that changes everything. You can see here a picture of the Orion Nebula, and you can see here a very hot star that is emitting radiation, and it's basically pushing the gas forward, pushing the gas outwards, and creating this big overdense area. And if we, for example, look to this image, which is one of my favorite ones from Guglielmitz et al. 2012, you have this dense, rich structure with a star here that is emitting winds, and then you have this crust, and because the gas was not uniform, you have this aperture here in this side of the picture. The radiation and the winds are compressing the nearby gas in these parts of the clouds. Because the gas is compressed because of the radiation, new stars are born, which is incredible, and that is why it's called stellar feedback, because somehow the output of the system acts as the input of the system, and that is incredible. There is the last feedback process that I'm forgetting, and these are supernova. There are two types of supernova. Maybe we can discuss it in a different chapter, but what is important is just dying star explodes, injecting massive energy and new materials into the galactic medium, and that also changes the properties of these clouds. For example, here you have what is the remnant of the Crab Nebula, which was a supernova that was observed during the day in 1054, and obviously it's affecting their surroundings. And that is all for today. That's all I wanted to tell you. I don't want to overload your brains with information. So the main line here is stars are created in molecular clouds. There are very dense areas with dust in the galaxy, and when a big star is formed, when a large star is formed, it emits feedback that affects again the structure of molecular clouds. So that's all. Follow me on Twitter, YouTube, on Facebook, and see you next week. Bye bye, guys.